We can represent an individual compound using a chemical formula, which are the element symbols from the periodic table, followed by subscripts that tell us how many of each type of element are in the compound. H2O means 2 hydrogen atoms and 1 oxygen. The 2 goes with the element before it, not after it. When one compound reacts with another compound, we have a chemical reaction. We can represent those using chemical equations. They're called equations because both sides must be equal in terms of which atoms were there before and after. In math, if one side of the equation has a value of 10, the other must also, so 2 plus 8 equals 5 plus 5 would be an equation. In a chemical equation, if there are 3 oxygen atoms on one side of the equation, there must also be 3 oxygen atoms on the other. Unlike mathematical equations, though, chemical equations go in one particular direction. On the starting side, all the compounds entering the reaction are called the reactants. They are the ones that will react. Basically, they are the ingredients of the reaction. On the ending side, the compounds are called products. They are what is made during the reaction. By looking at a chemical equation, you get a lot of information about the reaction. You'll know how many of each compound is involved, the types of atoms involved, and how many of each atom is involved. Here is the one big rule that will tell you if an equation is correct and if a reaction could actually happen or not. The atoms in the reactants must equal the atoms in the products. This is the case because of an important law of physics called the law of conservation of mass. The law of conservation of mass says that mass, so matter, is neither created nor destroyed during normal chemical and physical reactions. The only exceptions are extreme circumstances, like the creation of the universe. As a result of this law, whatever matter is present before a reaction must also be there after. So every atom involved in a chemical reaction must be accounted for in the chemical equation. Since matter cannot be created or destroyed, many reactions require more than one of each reactant compound to start the equation, and will make more than one of some of the products. To balance equations and make sure that no matter was lost or created, we use coefficients to represent how many copies of each compound are involved. Coefficients are large numbers, not a subscript or superscript, written in front of the compound that tell us how many of that particular compound we have. In math, if you see 3x in an equation, that means that you have 3 x's, or in other words, 3 times x. The 3 is a coefficient. It's the same here. 2H2O means that you have 2 H2O molecules. And since each molecule has 2 hydrogen atoms and 1 oxygen atom, you have 4 hydrogen atoms and 2 oxygen atoms, or 2 times each of these subscripts. By adding coefficients to 1, 2, or all the compounds involved in a reaction, we can count the atoms and be sure that we have the same number in both the reactants and the products. The process of balancing equations is called stoichiometry. To balance an equation, the first thing we have to do is identify all the different elements involved in the reaction and list them in a table. Next, we have to count how many of each element we have on the reactant side, and then how many on the product side. Then, again, write this down in a table. Now it's time to add coefficients. Initially, it will probably be trial and error, but as you get better at it, you'll be able to use your multiplication tables and knowledge of lowest common multiples to do it faster. Add a coefficient to one of the compounds that you think will balance one of the elements. Since most compounds have multiple elements in them, adding that coefficient will change the count for other elements too. So recount all the elements on the reactants and product side and remake the table. If they're balanced now, great, you're done. If they aren't, add a different coefficient, or add a coefficient to another compound, and then go back and recount again. Keep repeating this process until it's balanced and the equation obeys the law of conservation of mass. The equation shown in the picture is photosynthesis. The first reaction is unbalanced, and the second one has the correct coefficients added, so it is balanced. Draw a table for both equations, counting the atoms present, and then compare them. They should help demonstrate how this process works.